So let's take a look at lesson 15, where we are building from the part-part ratios we've been looking to part-part whole ratios, and building a new representation and tool, which is a tape diagram. So in the warm-up, students are looking at these and trying to determine if it is true or false. The complete lesson plan walks you through that very well, and kind of what we're looking for in that, and then using some of the formal language for that. In activity 2, before you get to the kids actually doing this, in the complete lesson plan, it kind of talks through you looking at making green paint and representing it using these snap cubes, with the idea that the ratio is 3 yellow to 1 blue, and talking through, okay, so how many, if that's cups, how many cups of paint would we have? And the kids will think that we have 4 cups of paint. And then kind of thinking through, if each cube represents 2 cups instead of 1 cup, how many cups of paint will we have? And the idea I think that they'll get to is that we have 8 cups. And so we could represent that by adding 3 more yellow cubes and 1 more blue cube, or we could represent it as just thinking about the fact that each cube represents 2 cups instead of 1. So that's going to build to the tape diagram that we want students to get to in the activity 2, but they won't be using a tape diagram. They are just reasoning here and doing the underlying conceptual work so that you can formalize that in the activity synthesis to be the tape diagram. Tape diagrams in Texas TEKS are called strip diagrams, and they have seen them in elementary math. However, they may not remember them from there, so you may be kind of helping them out as they work through that. Once they go through this activity in the synthesis, you're going to want to spend some time on that to help students work through the idea of a tape diagram and build that up. You can see here, this is the tape diagram for the third problem, where we are getting 80 milliliters of maroon paint by doing the original ratio was 5 milliliters of red to 3 milliliters of blue, but now each one represents 10, which gives us our 80. So the directions for that in the activity synthesis are great. They really will walk you through kind of how to represent that so that the kids have a good understanding of that. If you want a little more detail on that, I think you can also look at the answers for the next section. That kind of helped me out as I was looking through that and refreshing my mind on tape diagrams. So in the third activity, students are kind of could build their own tape diagram to represent this. Sometimes they won't need to. They may be able to figure out without it, and that's okay. One of the other ideas in this lesson is the idea of part compared to part. So we're doing part whole, but they're actually going to use that language. For instance, here in number 2, 3 parts oil, 2 parts soy sauce, 1 part orange juice. So using that language within the problem as well. So students may build tape diagrams there as well. Activity 4 is optional. I can't imagine you will have time for it, but if you do, fantastic. Students will invent their own ratio problem. I think the summary does a good job also of kind of showing what goes on in these tape diagrams, that this ducks to swans is 4 to 5. And altogether, that means here we have 9 animals in the pond. And if we're looking for this 18, that's just doubled the total, which means each one of these doubles, which is why there's the 2 in each box. So I think that's a good summary to kind of pull together this tape diagram idea and let students use it when they are doing part whole work as well.